Hi everyone, welcome back to the channel. In this series, we are looking at Leetcode problems, and today we'll be looking at Leetcode number 74, search a 2D matrix. So if you haven't already done binary search, I would highly suggest doing that one first because it is what we're going to use to solve this problem. But binary search is a little bit more straightforward because it's only a 1D array, where in this problem we are now given a 2D matrix. And we're going to have to think about rows and columns as opposed to just an index. So if you've already done that and you want to continue moving on, this is a great next step. The problem states you are given an m times n integer matrix, so rows times columns, matrix called matrix, with the following two properties. Each row is sorted in non-decreasing order. The first integer of each row is greater than the last integer of the previous row. Given an integer target, return true if target is in matrix or false otherwise. You must write a solution in O of log m times n time complexity. So one way that you could have solved this minus this statement here is just to iterate through your array and trying to find your target. But it's not really very efficient for this problem because we're given a sorted array, basically. And since it is 2D array, but if you think about the fact that this number is always going to be greater than the last item in the previous row, so this number, it's a completely sorted array. So we can accomplish that in O of log m times n, and we can do that by using our binary search. So we'll take it the same way as the regular binary search problem. We're going to take 2 pointers and find the midway point. Once we have the midway point, we're going to compare that to our target and see if it's less than, equal to, or greater than. And obviously, if it's equal to, we can just return true. They're not asking for the index, they are just wanting true or false. And if it's greater than or less than, we're going to move our left and right pointers inwards towards each other, depending on whether our target is less than or greater to our midway point. We'll move one of our pointers inwards and keep doing that until our pointers cross, and that's when we know if they ever cross and we haven't found our target, we can return false at that point. And that gives us the time complexity that we are looking for since we are not iterating through the entire array. So to start off, because we have a matrix, we want to keep track of the rows and the columns. So I'm going to create a variable called rows, and that's going to be equal to the matrix.length. And our columns, we can just grab the first index, and it'll be the length of our first array. Now I want to create my left and right pointers, and my left pointer is going to be at 0, and my right pointer is going to be equal to my rows times columns minus 1. So this is going to be the very last item in our entire matrix. And similarly to binary search, and like we said, we want to make sure that we never cross our pointers. So left always has to be either less than or equal to our right. And now that we're in our while loop, I want to grab the midway point and the midway point value. And our midway point is going to be equal to left plus the right pointer minus the left divided by 2. And the value of that midway point is going to be, well, we're going to take our matrix And for our rows, we'll say the midway point divided by the amount of rows that we have. And for our columns, we're going to take our midway point mod the rows. Because if this has a remainder, then we know that it needs to go to the next, it's going to end up in the correct position if there is a remainder. It won't, typically with division, it was going to just give us the lower bound number. And then we want to check if our mid value is equal to our target. And if so, we return true. Otherwise, we're going to check if our mid value is less than our target. And if that's the case, then we're going to move our left pointer equal to the midway point plus 1. And just like binary search, the reason why we do the plus 1 is we already know that it's the midway point is not our target, so we don't need to include it in the next iteration. And then otherwise, this means that it must be greater than, our midway point is greater than our target. And in that case, we can just update our right pointer to be the midway point minus 1. For the same reason, we know midway point isn't our target. We don't need to include it. And then that while loop will continue on until our pointers cross. And at that point, we'll return false. And we run our test cases and they pass. So that is searching a 2D array or 2D matrix. And it's very easy once you understand binary search. And overall, I think this is a pretty good medium-sized problem to work on. But that is all. If you have any questions, feel free to comment below. Or if there's any videos that you want to see explained further, let me know and I will happily do those. All right, thank you. See you in the next video.